Hi everybody, today I'm doing the Div 3 Codeforces contest. Let's go. Please load fairly quickly, thank you. Oh my god, so many words. I'm standing on different steps and there are height differences. What does this mean? Oh, I see. This is just a very badly written problem. Okay. Very badly written. Well, it's not that badly written. There's no easier way to write it, but it's definitely not easy to read. What's his size? Okay. So diff mod k equals 0. Minus 1 times k. Okay. Is it submitting? Accepted. Okay, nice. Swap two elements such they're both even or both odd. Okay. I guess I just sort it. Okay. Hyphen. Yes. Okay, submit that. That problem B was way easier than problem A, I believe. Oh, just after the 3-minute mark. Shame, otherwise I could have got another 2-minute solve. Accepted, okay. So you can jump to the right, you can get a path, number of tiles you stood on, and this is by k. Okay, this is very hard to understand again, but I'll give my best shot. I'm just going to guess what I think the problem means, and I will see that. Can k be equal to 1? Okay. Yeah, else no. And continue. Continue. Negative K. Okay, submit that. That was hard to understand again, but hopefully I didn't misunderstand. My biggest fear is I misunderstood the question and then I get a penalty. As long as it's accepted, I'm all good. So that was accepted. Calculates area prefix sums. Okay. Okay, I like this problem. Okay, so there's two cases. The first case is if the last element is equal to, I guess, n by n plus 1 over 2, then we do stuff, otherwise we do other stuff. Okay. Actually, let's do this first case first. Else, okay. Actually, let's just do this. Let's just copy paste. Do I even need the two cases, or does it just work? No. Okay, so my code isn't working properly. Oh. be intake 1 if okay, let's debug this case. Was it just always supposed to be intake 2? No, it's not. Oh, okay, that works. Now the problem is I kind of just debugged based off the sample, and I don't know how strong the sample is, so there's a very good chance it's wrong. So far it seems alright. I guess I'll just keep going. Okay, several potions. You can mix potions to form other potions. Have some unlimited supply of potions, but you don't want to know which ones. Okay. Total number of potion types. Potions. Costs. Once there is unlimited supply of. Well, so it's like a DP. Let's just use C++. Int n and k. This, we have some costs. A DP. Bool unlimited. And let's just say vector recipe. First, let's just clear. We'll clear variables, set our DP, set unlimited to true, to false, sorry, and clear the recipe. A bit dangerous doing global variables, but it's fine. Now we'll read in the free ones, and so these are the free potions, and we'll mark them as being free. Answer is x. dpx is not equal to no. If unlimited x. If not recipe, x.int for enter. Okay, let's return our DP. And print out our results. Oh, I forgot to even read the recipes in. Oops, I forgot to even read that in. Okay, let's read in that input. Okay, there we go. Okay, let's submit that. How many problems are there in this contest? I don't know. It's only 7 problems. Okay, a non-negative integer strictly less than 2 to the power of k. Okay. Accepted. F, and let's see. I'm just going to read G to see which one's easy. That's an interesting question. I don't know how to immediately solve that question. Actually, yes, I do. The question is just, can you get to from A to B, where the minimum is like, oh yeah, I know how to do this. Can you get to A and B, but you can't go to cities below? Yeah, I know how to do this immediately. There's like a slight edge case, which is really annoying though. Oh. Okay, let's just use LCA, my LCA weighted template. It's just, the question is, can you move to I to J, but you can only visit like some certain set of mountains. I don't believe E actually matters at all. You can just output that at the end, so you don't actually need that. So I kind of want to do like a, almost like a min. I don't want to change my template. My template currently does max, but I want mins. I'll just negate the edges. That's fine. And what's my MST template? Okay. Int nm scan it. I want everything to be 1 next here, just because it's easier for me. MST. MST. Okay, let's read in some edges. Negative, I guess, the minimum of the heights. St dot calculate the MST. Now I'm going to create the LCA. Auto edge in MST.chosen, true dot edge dot and edge dot first, yes, true dot build. And then now we're going to read in some queries. Dot, I guess, LCA between x and y dot. What does my template return? It returns the maximum. So I get that print. I guess if yes, otherwise no. It's only if it drops below 0, right? Yeah, okay. Let's debug this. Okay, so the error is somewhere here. Okay. Let's just debug this. I mean, that looked alright. Okay, if I'd gotten this quickly, I feel like I would have been alright, but I don't know what's happening. I'm just going to print, I'm actually going to print out these just to see if I'm reading in the input correctly, because sometimes I miss parts of the input. No, I seem to be reading the input correctly, so I don't think it's that. So I'm getting an... Am I trying to access something out of bounds or what? I hope it's not that my template is broken. Just to recheck, I can print out some stuff. Size. Okay, that's fine. Huh, I swear I tested my my template before, but I guess not. I wonder whether it's crashing on the first or second iteration. Oh, so this one actually worked. Although it was wrong. So the first time it's correct, and the second time it's just wrong. Like it just crashes. I do not know why my code crashes though. Oh, I believe it's because my I see. It's because I assumed that everything was connected, which is not true. Okay, so I can fix this. Okay, so I need to add some huge edits to my tree. Okay, let's just do this. I'm just going to do something very hacky. DSU graph n+1 graph dot. So this is more like first dot merge dot second dot first. Yeah, I'm basically handling when my graph isn't connected because I forgot to do that. What is going on? Wait, what? Why is my code not working suddenly? What's different to before? I don't know. First dot groups. Okay, it no longer crashes, but unfortunately now I'm getting wrong answer. Why am I getting wrong answer? I hope it's not because... I'm just hoping it's not because I misunderstood the question. So res is like the minimum. I'm trying to recall what my code is doing. Let me just print the new line so I can read it. This problem wasn't supposed to take that long. Okay, so what's the first one I get wrong? The first one I get wrong is this third case. So this query here from 4 to 7. Oh. Sorry, I understand. My spelling is the wrong way around. Though, just because I had spelling the wrong way around, so I actually do want to go this way. I want to go max. Oh, is that it? Okay. Submit that. I misread that problem slightly, and that cost a lot of time. Oh, sheesh, 19 minutes. That's not good. I didn't expect it to take that long. I got tripped up on my implementation details. That's probably terrible for my penalty now. Oh well. It doesn't matter too much. I just want like the two numbers that have the biggest similarity. So for any two digits that are the same, I want to maximize, I guess, the two ones that are the same. Oh, I should have thought about this a bit more before wasting time on G. Okay. Yeah, I did the problems in the wrong order. I should have definitely done it in this order. I did it in the wrong order and I'm gonna pay for that. Oh well. Try.min. If, I guess. Zero. Why would I get zero for? I'm supposed to have like, the zero is suspicious because that one definitely isn't supposed to happen. Oh, I see. Oh no, I don't see. So why is my try not working? Try.insert A1. Oh, I see. It's this sort of thing like if I might as well submit, because even if it fails pretest 1, then it will fail, then I won't get a penalty. So it passed pretest 1. Okay, I did that in the wrong order because that only took me 5 minutes, whereas G took me 19. So I lost out on about 14 penalty by doing the problems in the wrong order. I am done the contest now, but I don't think my standing will be very good. Oh, you know what? It's actually not bad. If I had 14 better penalty, I would have been 99, so I still wouldn't have beat these 3 guys, but people will overtake me probably because I did that in a terrible order. Okay, I'm going to go through my solutions soon. I'm not 100% convinced on my solution to problem D. This one was a bit sketchy, but we got there. Yeah, all these people are going to beat me, so I'm not going to end up on 4th place, but did I have any particularly good problems? Not really. Okay, let's go through the solutions. This problem is just really, really wordy. Nice errors in the statement. Okay. The solution is literally just, I guess, loop through all other people that you could potentially have a conversation with, and I'm just going to get the distance between, like, the difference between, I guess, Vlad's height and that person's height, and I store in this variable called diff. The requirements for that person to be able to have a conversation with Vlad is that difference in height must be divisible by k and must be strictly between 0 and m take 1 times k. Because it has to be greater than 0 because it says you have to be standing on different steps, so it has to be greater than 0. And also, if one person stands, if like the 2 people stands on the extremes, one person stands on the very first step and one person stands on the nth step, I guess then the height that corresponds to that is m take 1 times k. And so it's valid if this number is strictly between these 2 bounds. And I guess just summing the number of people, that's good enough. So this is an order n solution. Okay, problem B. Not loading. I'm really sad I did the problems in the dumb order. It's only because I didn't immediately see the solution to F, so I went for G first, but then I just was really bad at implementation. Okay, problem B is essentially, if we're able to swap any 2 odd elements, then it follows that we can sort all of the odd elements. Because if we just consider the odd elements, being able to swap any 2 of them, we can just apply any sorting operation like bubble sort or whatever, and we can definitely sort them. And so what you could do is you could get the list of all even elements, get the list of all odd elements. You could kind of sort the even elements in place. So I would swap the 2 and the 10, and I can sort the odd elements in place. So I would replace the 7, 1, and 3 with 1, 3, and 7. And once I've done that, I could check if the array is sorted. That works, but it's slightly difficult to implement. The easiest solution is just to construct the array B, which is the sorted, if I sort A and call that array B, so B would be 1, 2, 3, 7, 10 in this case. Then it's valid if, the first, how do I say it? The first element of A and the first element of B must have the same parity. The second element of A and the second element of B must have the same parity, and so on. So all I do here is I sort them. In Python, this is a very convenient function called zip, which means that you kind of pair up the elements. You pair the first element of A with the first element of B, and so on. And basically, for all matching pairs, we need to check that they have the same parity. And that's my solution. There's a chance that my solution to E is wrong and it gets hacked, but hopefully that doesn't happen. Problem C is, most of the problem statement is a red herring. Basically, there's 2 cases. The first case is if the first element is equal to the last element, then we simply need to check if there's at least k elements of that color. And that's because, like, if this was a 1, and let's pretend, for example, that the last element was a 1, then, I mean, there's no reason to use any other colors. We might as well just step on exactly k1s and get to the end. So all I do in that case is just check if there's at least k elements. Okay, and I guess if they have different elements, again, there's no reason to keep going onto many other colors. So in our case, it's definitely, like, since we start on a 1 and we have to end on a 4, the optimal path is just visit 3 1s and then visit 3 4s in that order. And that's literally it. There's no reason to visit any other stones. So what I do is I just find the third verse, like third 1, and I would find the third last 4 and just make sure that this 1 is, like, comes before this 4. That way I can do all 3 1s before all 3 4s. So in my code, I get the list of all elements which match the first element, and I get the kth one. And then I get all elements that match the last element, and get the kth last one. And if x is less than y, then that means that I can visit all k of the first color before all k of the second color. You can also do, like, a classic subsequence trick or whatever. Like, you can, yeah, there's a way to do it just by checking if a sequence is a subsequence of another, which I probably should have done in hindsight because that would have been faster. Okay, this problem is, honestly, like, my code is super messy. I wonder if this part is necessary or not. I don't think it is. Yeah, I don't think it is. That was just there. I'm not sure why. Pretty much all it is, I guess, let's pretend that an element isn't missing. Like, from the prefix sum array, we can reconstruct the original array. So if an array has the prefix sum of this, the original array must be 6, 2, 4, 3. We copy the 6 from here, and then all of these ones are just the adjacent differences. So we can, for any prefix sum array in general, we can reconstruct the original array pretty easily. And all my code does is I check if there's a 1 in this array, if there's a 2 in this array, if there's a 3 in this array, and so on and so forth. And I kind of count the number of elements from 1 to n that are in our current array. And then there's kind of two cases. If the last element is equal to m times n plus 1 over 2, then exactly n minus 2 of them need to be found. Otherwise, n minus 1 need to have been found. Now, that was really confusing, so I'm going to break it down. I guess case 1 is a of n equals n times n plus 1 over 2. Like, why would I even think of this as a case? Well, that's because if there wasn't an element missing, like, if there isn't an element missing, then for any permutation, I guess the last element would just be the sum of all of these elements, and the sum of the first n positive integers is equal to n times n plus 1 over 2. What this tells me is, if I have something like this, for example, 6, 8, 12, 15, if I kind of convert that into the original array, I get 6, 2, 4, 3. And I want exactly n minus 2 of these integers to be, I guess, unique integers between 1 and n. Why? Because I can take this 6 and I can split this 6 up into 1 and 5. And then this would be a valid array which could potentially match this one. If, for example, like this 6 could have been like a 1 here, and then that would have worked. So basically, if the last element is n times n plus 1 over 2, what we require is we need one of these, like 12. We need to be able to insert an integer in here. Like, we need to be able to insert an integer somewhere near the beginning, which would lead to a permutation. And if you think about the differences, like here, that's basically equivalent to choosing one of these differences and splitting it into 2 elements which sum to it. And that's why we need, I guess, n take 2 of them to be unique integers between 1 and n, because the last one, we can definitely split it up into the 2 remaining elements. And we can definitely split it up into the 2 remaining elements because we know that the sum of them equals n times n plus 1 over 2. So if we, for example, if I know I want to split up, if I want to split up this 6, I know that since I already have a 2, 4, 3, and a 4 and a 3, I'm missing the 1 and a 5. But the 1 and 5 definitely works because the sum of these elements does match the 15, which we are expected to get. I guess the second case is when, sorry if that wasn't clear at all. If it's not equal to n times n plus 1 over 2, we need a slightly stricter condition. So for example, if we have 1, 3, 6, in this case, it can't be that we're missing some number in here because we need this number to be we need this last element to be n times n plus 1 over 2. So in this case, the element which must be missing must always be, I guess, the n times n plus 1 over 2. And that must always be the last element which is missing. And in that case, we can just check that it works. So those are the two cases. Sorry if that didn't make sense. If you don't understand, you can post a comment. Wow, no one's overtaken me. How's that happened? Okay, in this problem E is very simple dynamic programming. This part is all just reading the input and resetting the DP array, so this is not important. All that matters is kind of this function, which is our DP function, but let's just treat it as recursion. If the element x, I don't know how to pronounce this, Nastia? I don't know, but if Nastia has unlimited of this potion, I should define dpx. I guess this function, given a potion, it returns the minimum cost needed to obtain that potion. So if she already has access to unlimited number of that potions, the answer is 0. Otherwise, the answer, well, at first we can just buy it for a cost of c of x. And if the recipe to make that potion, if there is a recipe to make that potion, I guess we can just take the sum of the costs of each of the ingredients and then compare that against just buying it. And that's it. It's a very easy problem, actually. Problem F is I used my template for bitwise XOR tries. But essentially, I'll explain it to you. So we kind of just need to study this function. And essentially, if we could just consider each bit position, if AI and AJ are both zeros or both ones, then we can definitely choose to set the corresponding bit in X such that the bit set in this expression is will be 1. Okay, that was a terrible explanation, so I'm going to try to explain that again. How do I do that? Okay. So I guess the first thing we can notice is that every bit is independent. So we can choose each of the bits in X independently to try to get the corresponding bit in this output set or not. So I guess we can just concentrate on a single bit or not. Like, imagine if AI is equal to 0 and AJ is equal to 0. Then we can just choose X equals 1, and this expression will evaluate to 1. If they're both equal to 1, then I can choose X equals to 0, and the bit gets set. But if they have differing bits, then if they have different bits, then no matter what X I choose, the bit cannot be set. Because if I choose X equals 0, the expression evaluates to 0. If I choose X equals 1, the expression also evaluates to 0. So what I'm trying to do basically is, what I would ideally want to find is, I want to find two elements that have a lot of bits in common, like the same bits. Like if AI in base 2, I guess in base 2, it looks like this, and AJ looks like this, then I guess in my results, I can get, like, every time they have the same corresponding bit, it's possible for me in this output to also have that bit set. So in this most significant bit, they wouldn't be able to be the same, but all of these ones where they match, they would be able to be the same. So what I'm actually trying to do is I'm just trying to find the two elements which have the most bits in common, but I want to give priority to the bits that have the biggest value. So what this actually ends up is, becoming is I want to find the pair of I and j. I want to minimize AI XOR AJ. And actually you can prove that the result is equal to almost like the inverse of AI XOR AJ. If you only consider k bits, every number has k bits, you can prove that this is the expression. So what I do is you can do this using a trie. So a trie is a very famous structure, like this binary trie. I'm not going to explain it in detail, but my binary trie allows me to do two operations: insert an element, insert like a value, and query x finds the minimum possible value of x or y for any y in the trie. There's many tutorials. I won't go into how this works, but basically I use this structure to find the pair x and y that have the minimum possible XOR, which I call best. Implementation details aren't that important. Like I don't know. I'm just like, my I is like a possible value of y, and I try to find the other element already in the trie which minimizes that XOR y, and then I do some maps to find out which elements they correspond to. It's just implementation details. Essentially, like once we found the optimal x, y, and best, then if we have to choose an x, well, every time that both AI and AJ both 0, like have that bit set to 0, I should set that corresponding bit in x, which is what I do here, and then I just output that. Okay, hopefully that made sense. Or not. Okay, I guess in problem G, we can reduce, I guess the key observation is the problem reduces to, can you get from node X to node Y only visiting nodes with heights, at most AX plus E? This is the real question. Because you note that like at any point in time, if you are at heights H, I mean your energy is always equal to E plus H minus AX. Like, for example, if I start the map, if at height 3 I have an energy of 0, then at height 1 I'm definitely going to have an energy of, I guess, -2. Wait, did I get this the wrong way around? Yeah, I got this the wrong way around. It's this way around, this is what tripped me up. It's basically this. If at height 3 my energy is 2, then at height 4, like no matter where I am at height 4, I'm definitely gonna have energy 1. At height 5, I'm definitely gonna have energy 0. So actually, this is what it kind of reduces to. So what I actually just do is, I'm reducing this to find like what is the minimum possible maximum height on the path from X to Y. So across all paths from X to Y, which path minimizes the maximum height that you pass through? And the way I do this is I kind of like for each edge edge between X and Y, I assign it the heights, I guess the maximum of HX and HY, and now this reduces to what is the minimum possible maximum weighted edge on any path from X to Y. That means across all paths from X to Y, I want to minimize the weight of the like maximum edge that I pass through. And this is a very famous question. So what I do is I just construct the MST. But I guess we can reduce this even further. But hopefully you get what this means. It means that I want to find a path from X to Y, but I want the largest weight of any edge on my path. I want that largest weight to be as small as possible. And you can actually reduce this to, I guess, build the minimum spanning tree on the graph and then query what is I guess the maximum weight on the unique simple path from X to Y. This is a bit complicated, but essentially, across all paths from X to Y, it's optimal to take the path that follows along the minimum spanning tree. And if I want to find this maximum weight, I use LCA and jump pointers. I'm not going to get into the details. Basically, I use my templates to build the MST. Because the graph isn't connected, I add some dummy edges with weights up to infinity, just so I can use my LCA template. Then I just query the maximum weight on that path, and if my initial height plus energy is greater than equal to the maximum height that I need to pass through, then the answer is yes, otherwise it's no. Sorry if that didn't make sense again. Anyway, that's about all I have for this contest. I'm going to refresh one last time, and it looks like I did end up in ranked 4. Even if I had done them in the optimal order, I would have still ended up at rank 4, so I'm not upset about that. Wow, I beat a lot of people. Anyway, thank you so much for watching, and I'll see you guys next time.